Hey, hello everyone. I hope you are doing great. So today we have come up with another question that is present on the lead code. So it's a combination sum second problem. So it's a newer version of a problem that we just did yesterday. So it was combination sum one. So we'll see what this question is about. Okay, and what is the difference between that question and this question, and how we can do it differently. Okay. So we have a given a collection of candidate number, that is the candidates, and a target will be given to us. We have to find all unique combinations. We have to find all unique combination in candidate where the candidate number sums to target. Okay. Now, one basically thing that we need to take care is that each number in the candidate may only be used once. Okay. So in the earlier problem that we did, which basically in which so in that one we can use one number of times, any number of times, but here it is mentioned that we can only use one number only once. Okay. So for example, and the second question is that the solution set must not contain a duplicate combination. Okay. So these are the two conditions that we need to take care while solving this question. Okay. The first, now we'll see the example. So in the example, in the candidate array is 10, 1, 2, 7, 6, 1, 5. Okay. Now the target is 8. Okay. Now the first array that we got is 116. So it is 1, then this 1, and then this 6. And it should be in a sorted order. The second one is 1, 2, 5. The third one is 1, 7, and 2, 6. So in this way, we have to basically return the list of all the unique combination, which will, if we'll add them, they will be equals to a target. Okay. So let's see one by one. Okay. So let's go one by one. We will see one by one. Okay. Now let's say we have this particular problem in which the array is 1 1 1 2 2. Okay. Now what are the combination that we can have? Okay. So these should be unique combination. So one combination could be 1 1 2. Okay. The second combination could be 2 comma 2. Okay. These are the two combination that we can have, and we have to return the result. So guys, if we have done similar problems in which we can take a same element number of times. So if you haven't watched that video, so please go and check out that video and then only come here. Okay. So in that way you will know that how that problem was solved and what was the issue with that problem. And okay, now we can implement. So we will first go with the brute force approach. Okay. So brute force approach will be, we will use the same algorithm that we have used here. Okay. So in that algorithm, what we have, so we have index, and we have index 0, we have target, and we have a DS. Okay. Here we have a combination that either we can pick the zeroth element again, or if not, we can pick the next element. So we have pick or not pick. So again, we can go with zeroth element, then target minus this one, then DS, and the pick next element. Okay, target minus a of I comma ds. Okay, but now here the we have to basically just modify the problem is that we cannot pick this element, so we cannot go in this particular loop. We can just go here. Okay, so in that case, what the time complexity would be, so basically the one thing that we have to also return is that it should contain unique element. Okay, it should contain unique element, so we have to basically maintain a set. Okay, set of list of integer to store the answer. So the time complexity would be big O of 2 to the power n into k is the number of basically number of elements that are present in the set, number of unique combination, and it would be k of log n. Okay, why k of log n? Because we are inserting these elements into the set so that we can get the unique element. Okay, we can only return the unique element. So this one is a brute force approach. So in this one, the time complexity we go of 2 to the power n into k log n. Okay, now we will see that how we can do it in a better way. Okay, and how we can do it in a better way. Okay, so let me just again do. So our element, okay, 1 1 1 2 2. Okay, we have a target 4, and our answer was 1 comma 1 comma 2 and 2 comma 2. Okay, now we will see how we can do this here. Okay, so okay, so we have to basically find the subsequence. So what we can do here is that, So we will check. So for example, if we pick, let's say I have this element f of 0, I am at 0th position, I have a target t, and I have a data structure ds. Okay. Now here I will check. Here I will check if can I pick the first element? Can I pick the 0th element? If I can pick the 0th element, I will basically move to the next pointer, that is 1 comma t minus a of 0th, and my pointer will contain 1. Okay. Now the second one is that I can also pick first element. Okay. Now the first one is, can I pick 0th element? Yeah. Now second one is, can I pick first element? Okay. Now we will see that can I pick first element. So if I have already picked one element, first 0th element, then so can I pick the can I pick the element that is present on first index? If I will pick this element, then I will get the duplicate element. Okay. Because the set, the combination that I am making, it will contain the element 1 at its first position, so it will be a duplicate element. So we will not iterate for this one. Okay, we will not iterate for this one. Here in the at the third index also, at the second index also, we have 1, so we cannot do this. Okay. Now at this particular point, f of 3, now I am saying that can I pick the third element? Can I pick the third element? I can pick, because it is not 1, it is 2. Okay. So the the unique combination could be 1 2. Okay. Now this one, now it will say that move to the basically next pointer, that is a fourth, and the target will be 2, and my list, my data structure will contain 2. Okay. This is the one, right? Okay. Now here, we I can update this one with. Okay. Now here, now at the fourth, can I pick this one? Can I pick this one, the fourth one? I cannot pick this one, because I have already a list which contains 2 at its initial position. So it will, if I will again ping it, so it will be just like this: 2 2 again, 2 2 again, 1 1 2 1 1 2. So it will be just duplicate element, so there is no point to take it. So I cannot pick this element also. Okay. Now now again recursion comes here. Okay. So let me just do one thing. Okay. Now recursion comes here again. Okay. Now here again I will have 5 possibility. I will check. Okay. Now I am at first index. Okay. First index, I will check. Can I pick the first index? Can I pick the second index? Can I pick third index? Can I pick the fourth index? Okay. So first I will check. Can I pick the first index? Yes, I can pick the first index. So my element will be, I will move to the 2, t minus a minus 0. It should be, I will update it to t would be my 4. 4 minus 1 is 3. It will be t. So it would be 2 comma 2, and my array contains 1 1. Okay. Now can I pick the second element? So if I pick the second element, okay, now if I pick the second element, I would again get the duplicate element. So if I will show you, so if I go with this particular one, it would be 1 comma 1. Okay. Now if I pick the second element again, it would be again 1 comma 1, which will make the duplicate element. Okay. So there is no point to basically consider this one. Okay. So I cannot pick the second element. Okay. Now third, can I pick the third one? Yes, I can pick. I will just go F. It will be my 4. The element will be 3 minus 2, that would be 1, and the value would be 1 comma 2. Okay. Now can I pick the fourth element? Can I pick the fourth element? I cannot pick the fourth element, because I have already picked the third element, in which there was an index, there was a value of 2. So if I, so it will be, if I 1 2, it will again 1 comma 2. So there is no point to pick this duplicate element, so it would be null. Okay. Now again I'm coming here. Okay. Let's see. Okay. Now here I have again the possibility. So I can I pick second element? Can I pick third element? Can I pick fourth element? So can I pick second element? Yes, I can pick. If I just see what is the second element, yeah, it is 1. Okay, so let me just decrease the size a little bit. Okay. Okay, okay, okay. So can I pick now second element basically? Can I pick second element? Yes, I can pick second element. I will just check. Can I pick second element? Let I can pick second element. So it would be I will move f of 3, comma. This target would be 1 and this contains 1, 1, 1. Okay. Can I pick third element? Yes, I can pick third element. So it would be f4, target would be 0 and it would contain 1, 1, 2. Now, can I pick fourth element? I cannot pick fourth element because I've already picked the third element and this will be a duplicate one. Okay. Now I will just again move. Okay. Now here I have only one possibility. Can I pick third element or can I pick fourth element? I will have two possibility. Okay. Can I pick third element? I cannot pick third element because my element, the element that is present on third index is 2 and my target is 1. So my A of I is less than target. So I cannot pick this element. Okay. I cannot pick this element. Same, I cannot pick this fourth element. So from here, it will go move. It will go up. Okay. Now here my target index is basically I got my target as 0. So this will be my one of the combination that will be 1 comma 2. Okay. I will put it in the my answer basically array. It will return the value from here. Okay. Now it will go here. Now we have this particular one f4 1 comma 1 comma 2. Can I basically, is there any possibility I can do something here? I cannot do anything because there is one thing that is that so what I will check f of I cannot pick this element since the element that is present on fourth is 2 and my a of I is less than target 2, so I cannot do this one also. Now here also, now I am here. Okay. If I go here, okay, now here I have, let's check. I'm at the fourth position. Okay, so I have only one possibility. Can I pick fourth element? So if I pick fourth element, okay, if I pick fourth element, so what I will have, if I will pick fourth element, I will have f of 5, target will be 0 and my index would contain 2 comma 2. Okay, now I got the target, so I got the result that is 2 comma 2 and I will return my result from here, and it will return my result from here. It will again go here and it will return the result. So my answer array contains these two elements 1 comma 1 comma 2 and 2 comma 2. Okay, we have also removed the duplicate element because we have basically the first thing that we have to do is we have to sort the array. We have to basically sort the array so that we get the element in an increasing order. Okay, we have to sort the array in an increasing order. Okay, in this way we have calculated all the subsequence. We have basically we are not considering that element if the element if the previous element is equal to the current element. Okay, so in that way we can remove the duplicate element. Okay, and we are also checking now, so we will check how this can be. Okay, we will just check the brute force how it could be. Okay, so it would be something like this. Okay, so the problem okay, so it would be like I have zeroth index, I will pass my index, there will be target and there will be a data structure. Okay, and there will be some answer array in which I will put all the my data structure. Okay, so I will check if my target, if my d is equals to 0, it means I have to put that element in my ds array. Okay, basically I have to put whatever I've stored in my ds, that will be my one of the unique combination, so I can put in my answer. Okay, and I can just return from here. Okay, the second thing what I will do, I will iterate from for I equals to int I less than n I plus plus, and I will again check here if my I is greater than n and my a of I is equals to a of I minus 1. what we are doing here, that if the current element, the previous element, they are equal, so I'm just continuing. I'm not taking care of that, basically that index, because I'm not pushing that element into the recursion, because there is no point to do that. If I will do that, then it will just give me the duplicate combination. Okay. The second thing that I'm checking is that if my a of I, if it is less than, if it is greater than target, yeah, if it is greater than target, then I have to break. Why? I will not go with any of the element. So why I am doing this, that I'm saying that if my a of I is greater than target, so if I cannot do with 3, then I will definitely not with 4, 5, 6. If I cannot do with 3th index, okay, so let's say here it will be 2. Now it will be a sorted array, 2, 3, 4, 5. Okay, if I cannot do it with 2, then definitely I would not be able to do it with index 4, index 5, index 6. Okay, so that's why I'm not going with any of the element here. I'm just returning, I'm just breaking the loop, and I'm just moving to the next index. Okay, I'm just breaking the whole loop. Okay, so in this way this can be done. Now okay, then I will just basically, what I will do, once it is done, what I will do, I will basically insert that current element, in my array, and then I will just again call the, basically this function, f function. I will again just call this f function with I, with I plus 1, and target will be a of I, and my ds will contain, I will pass ds, and then I will also remove ds, so that I can basically, once I will go from here to here, I have to pop this element. Okay, so now we will see the Java. Now we will first check the time complexity of this particular algorithm. Okay, so the time complexity would be, so let's see, let's see the time complexity. Okay, so the time complexity will be big O of 2 to the power n, because we are doing the recursion and we are checking for every element, and it would be n into k. Why k? K is the number of unique combinations that we are making, and that's why we are taking basically k. And the space complexity would be big O of k into x. So k is the number of unique combination, and x is the number of elements that are present in that particular basically list. Okay, so this is a space complex. This can, we can basically ignore it, because this is basically we have to return the answer, so we can ignore it, and we can just see that the space complexity that we are taking is big O of 1, and the time complexity that we are taking big O of 2 to the power n into k. So earlier the type complexity was b of 2 to the power n into k log n, because we have to use set there. Okay, we have to use set so that we can remove the duplicate element. But here now we are shorting the array. We are not taking, we are not considering duplicate element. So in that way the type complexity has been reduced from 2 to the power n into k log n to 2 to the power n into k. Okay, so that's why the type complexity is this one. Now we will see the Java code, and let's see. Okay, so this is the question. So we will see one by one. Okay, so this is the basically function. This function will be called. It will be passed as candidate array, and the target will be passed. I will create my answer array, and ds array, that will be my, that will basically store the combinations. Okay, I'll first sort the array so that I will get all the element in a increasing order. Then I will call this function find combination, in which I will pass the first index as 0, the target, candidates, ds, and answer. All I can pass. Okay. Now here I'm checking. I'm checking that if I got a target as equals to 0. If I got my target, what I'm doing, I'm inserting that ds, whatever element, whatever combination that are present in ds, I'm inserting that into my answer array, and I'm just returning from here. Okay, if my target is 0. Okay, now I'm iterating from end to a dot length. I'm iterating to all the elements. I'm checking, and here I'm checking if ai is greater than end and ai equals to ai minus 1, then continue. What I here I'm doing is that I am basically skipping if I get any if I get two unique element consecutively. Okay, so that I cannot have duplicate element in my ds array. Okay, so this is the way that we are doing, and here I'm checking that if my a of I is greater than target, then I'm not going with any recursion below this. I'm just breaking it, because if my a of I, if the index, if a of I is greater than target here, which we have already discussed, if this one is greater than target, then we are not considering any of the indexes. Okay, we are just breaking them. Then I'm adding that element. I'm just again calling that basically this function recursively, and index will be by I plus 1. The target will be reduced by target minus a of minus 1, and I will pass the array as a d as answer. And once it comes back, I'm removing that element from that one. Okay, why I'm removing that? Here it was 1 1 1. Now if I come back, it should be 1 1. Okay, that's why I have to remove that. Okay, then I'm just returning the answer. So in this way, we can solve this particular problem. So I hope you guys really like this video. So please do like, subscribe, and please do like, share, and subscribe because it motivates me. So thank you guys. Bye bye. Take care.